In this chapter, we'll go over some old and new reactions that we are going to use in order to prepare carboxylic acid. This one is an old one. This one is from chapter 14. And we can oxidize any benzylic hydrogen into a carboxylic acid. It doesn't matter how many benzylic hydrogens we have around the benzene, all of them, because we are using a very strong oxidizing agent, all of them are going to be oxidized into a carboxylic acid. Remember that if there's no benzylic hydrogen, there will be no reaction in there. This reaction we can use in the synthesis of carboxylic acid. Let's have an example over here. So let's say starting from benzene, we want to go ahead and prepare para bromobenzoic acid. So the first thing that we need to do is we know that the bromine directs ortho and para, and the carboxylic acid to add to the benzene, you add it through Friedel-Crafts. So you would need to have a carbon, at least one carbon on the benzene. We're going to do AlCl3, and then we're going to get the toluene. Now, once we get the toluene in there, we can simply introduce the bromine. You want to introduce the bromine in this step because the CH3 directs the ortho and the para. So you're going to get both isomers. You're going to get the ortho. You're going to get the para. We only need the para in there. So this is going to be the bromine plus the ortho. So we're going to take the ortho on the side and carry on with the para. You can simply do oxidation with the Jones reagent. And chromic acid is a strong acid that oxidizes the benzylic carbon over here. So you have your oxidation of that benzylic carbon. And again, oxidation happens on this carbon because this carbon has a benzylic hydrogen. So this one will be oxidized into a carboxylic acid. Another way to prepare carboxylic acid is to do oxidation of primary alcohols and to use a strong oxidizing agent. Just primary alcohols, not secondary, not tertiary. And we did explain this in the chapter 8 in organic 1. So primary alcohols, they do have two primary hydrogens in there. So you can oxidize the alcohol into a carboxylic acid by any one of these oxidizing agents. The oxidation is normally carried by the loss of the hydrogen on the oxygen and the loss of the hydrogen on the carbon. So you lose two hydrogens in there and you get the intermediate. The intermediate is the aldehyde. But you cannot isolate the intermediate in these types of reactions. So you're going to get your aldehyde here, which is going to be the intermediate. In this reaction, because the chromic acid or the sodium dichromate or the KMNO4, all of those are very strong oxidizing agent. This guy, it cannot be isolated. The hydrogen over here will get further oxidized immediately into a carboxylic acid. So this is why primary alcohols, they turn directly into a carboxylic acid. And the oxidation into a carboxylic acid is two steps in there. You get the intermediate, but the intermediate cannot be isolated because the oxidizing agent is very strong. You go straight into the carboxylic acid. Notice over here that I didn't add any carbons. I have two carbons on the benzene. Here I do have two carbons. So the carbon that is connected to the alcohol is the one that is going to turn into a carboxylic acid. Just as a revision, secondary alcohols, they don't turn into an acid. Secondary alcohols, they lose a hydrogen from this carbon and the hydrogen from this oxygen, and you're going to end up getting a ketone. There will be no further oxidation for the ketones in there. Primary alcohols, if I use a milder oxidizing agent, then in this case, I will end up isolating the aldehyde. So it really depends on how strong the oxidizing agent is with only primary alcohols. So primary alcohols can form two types of products. They can form either the aldehyde in case I'm using a mild oxidizing agent, or they can form the carboxylic acid in case I'm using the strong oxidizing agent. Let's have a synthesis example. So starting with this compound in here, I want to go ahead and prepare this compound in here. Okay, so the first thing that you would need to do is look at your reactant and compare it to your product in there. So my reactant has 1, 2, 3, and 4 carbons. My product, see my product in this case, my product has 1, 2, 3, 4, and 5 carbons. So in this case, what I did over here is I added 1 carbon. And that carbon is the C in the cyanide. So, and of course, I changed the primary alcohol. So here, notice I changed the primary alcohol into a carboxylic acid. So this means that this is a simple oxidation reaction at the end. But first, I would need now to substitute the pyramine by the CN. This is an easy step in there, and this is a revision from organic 1. So this is a simple substitution reaction. Go with the SN2 in there. I'm starting with an alkyl halide. This carbon over here is a partial positive carbon. The CN is negative. This is going to be my nucleophile. This is a strong nucleophile because it is a negative charge. The mechanism is going to go by a direct SN2 reaction. It's a one-step reaction. The CN is going to come, attack the carbon, and the pyramine is going to leave. So this is how I can introduce a cyanide to my product in there. So over here, I don't have to worry about stereochemistry. I don't have a chiral center to start with. So I do have my CN in there. Here you go. So I added my cyanide in there. Once I added my cyanide, all I need to do is a simple oxidation because now I have my 5 carbons. I have 1, 2, 3, 4, and 5. So all I need to do is now change this OH into an acid. This is what I need to do. The carbon will stay the same. So this carbon over here is this carbon over here. It's going to stay the same. I'm not adding any carbons in there. This is going to be a primary alcohol. So all I am doing in there is I am doing an oxidation with a strong oxidizing agent. This means that I am losing those 2 hydrogens in there, creating a double bond between the C and the O. This is going to be the intermediate aldehyde, and then this hydrogen will get oxidized immediately after that. I can use the Na2Cr2O7 in presence of an acid in order to get the carboxylic acid. If you look over here for this synthesis reaction that we just did, this is a 2-step reaction. The first step is the direct substitution, and the second step is the oxidation in order to get to your product. So if you want to summarize those steps in there, you write step 1, you did NaCN. If you want to use a solvent, remember that SN2 goes with polar aprotic solvent. So we can use with the sodium cyanide, DMSO, any solvent that has no OH or no NH. So DMSO, THF in there, DMF, acetone, all of these are polar aprotic solvents that we can go ahead and use. I'm just going to go ahead and choose THF in there. And then the second step is simply doing the oxidation, Cr2O7 in presence of H+. Remember that there are other oxidizing agents also that we can use other than the sodium dichromate. We can use the chromic acid, Jones reagent, or the KMnO4, and all they do the same job. I can prepare carboxylic acids starting with alkyl halide and the Grignard and carbon dioxide. This is a reaction that we went over in chapter 16. So starting with an alkyl halide, any alkyl halide, and we said that this carbon over here can be an sp, an sp2, or an sp3. In this case here, it is an sp3, but it can be an sp or an sp2 hybridization. It doesn't matter. You create your Grignard. After you create your Grignard, if you want to introduce just one carbon, so see here, I am replacing the bromine with the carboxylic acid. So I just want to introduce just one carbon in there. Go ahead and use carbon dioxide. Fuse carbon dioxide, then all what you need to do is a simple reaction in there between the nucleophile of the Grignard and the electrophilic site of the carbonyl in the carbon dioxide, and you get your product. The reaction is a two-step. Step 1 is the carbon dioxide. Step 2, this is very important. That step over here is the protonation step, because the oxygen will be a negative charge, so you would need to protonate in order to get to your carboxylic acid. So let's say if I want to start with this alcohol over here, and I want to synthesize or to prepare this alcohol over there. Okay. Now this one is a hard example. So all what you need to do is, again, look at your products, compare it to the reactants, and see what did you do over here. Actually, I did multiple things. 2 things I did over here. I added 2 carbons, and every time you see that your product has an addition of 2 carbons in there, this means that somehow throughout the way of the synthesis mechanism, you added an epoxide. When we add an epoxide and you break the ring, then in this case, you will end up adding 2 carbons in there. These are the carbons of the epoxide. They are here. And then over here, what I did is I added also a carboxylic acid. So I added 2 things. Adding the carboxylic acid can come from a Grignard plus carbon dioxide. But to have a Grignard, I need to have a halogen in here. So if I have a halogen in here, like a bromine, I can simply replace the bromine with a carboxylic acid, like I did in this example over there, replacing the bromine with a carboxylic acid. So let's first worry about adding the epoxide in there. So let's add these 2 carbons first, and then introduce the carboxylic acid. So the first thing that we would need to do is we need to create a Grignard out of this one. To create a Grignard out of this one, I want to get rid of the OH. And this is a revision reaction in there. So to get rid of the OH in there and introduce a halogen, this is going to be a substitution reaction. This is a tertiary alcohol. So we are going to do an SN1 reaction there with HCl. Either HCl or HBr, it really doesn't matter. In this case, so I can use HCl or HBr in there. I'm gonna use HCl, so we're gonna have a chlorine in there. Since it's a tertiary alcohol, this is a substitution reaction. It is an SN1 reaction. The first step is the protonation of the oxygen. You make water. Water is gonna leave. You create your carbocation. Please review these reactions. And then the chlorine is going to attack. So you form a tertiary alkyl chloride. And this is what we want, because now what I want to do is I want to change this into a Grignard. So I'm going to react this with magnesium in presence of a diethyl ether in there. And here you go. This is going to be my Grignard in there. Again, I can use the bromine. So now this one is going to be a bromine if I do so. Okay, the reason why I want my Grignard, because as I said, I want to go ahead and add 2 carbons. And to add 2 carbons, I want to do a ring opening of the epoxide in basic medium. So here you go. This is going to be my Grignard. This is partial positive. This is partial positive. The Grignard is my nucleophile. So now the nucleophile is going to come and attack the epoxide and open the ring. So when the Grignard opens the ring in there, what I did over here is I added the 2 carbons of the epoxide and the O negative in there. Okay, ring opens, forms an O negative. So this means that I would need another step in there, which is the protonation step. Any solvent that has a hydrogen can do the job. I'm going to do water. And then we're going to form our alcohol. Here you go. So now I want to replace that OH with a halogen. We're going to do exactly the same thing again. I'm just going to use HCl because I used HCl at the beginning. If you used HBr, just go ahead and use HBr again. So I'm using HCl in here, replacing that oxygen or that OH with the chlorine. And the reason why I want to replace it with the chlorine, because I want to replace that chlorine with a carboxylic acid. And I can only do this if I change this into a Grignard reagent and then react it with carbon dioxide. So I'm going to end up adding my magnesium solid in presence of diethyl ether. And we're going to have our MgCl in there. Okay, and now we can use the carbon dioxide. So add the carbon dioxide over here. Here you go. This is a negative charge. I added my 2 carbons in there, and they should stay along the way over here. So the negative charge is going to come, attack the partial positive carbon, form a negative charge on the oxygen. So now I am going to make a bond between this carbon over here and the carbonyl. So let's go ahead and put the carbonyl in there. This is going to be an O negative, and then you're going to have your double bond O in this case. So I made a bond between this carbon and this carbon, formed a negative charge on the oxygen, and on that carbon I have my carbonyl. My last step is going to be the protonation. So any solvent that has hydrogen can do the job. In this case, I can use either water or an acid, whatever is available. I'm just going to go ahead and use water, and we're going to end up getting our product in this case. So you have your carboxylic acid. I added my two carbons through the epoxide, and then I added my additional carbon by simply using a Grignard and carbon dioxide. Another reaction that forms carboxylic acid is the oxidation of the double bond. It's the cleavage of the alkene in the presence of a very strong oxidizing agent. It can be any of those two, or I can use ozone in presence of a peroxide. So all of these, peroxide will increase the strength of the ozone, make it a very strong oxidizing agent. All of those oxidizing agents will break the double bond in half. You're going to stick an oxygen to each end of the double bond, and all the hydrogens around the alkene, if there are hydrogens, then these are going to turn into an OH. And this is how you get your carboxylic acid. So to get the carboxylic acid, you should start by having hydrogens around the alkene in there. This one is gonna be two OHs, and we said that it's going to be very unstable. This is carbonic acid, and the carbonic acid is going to dissociate into carbon dioxide and water. So you're going to end up having in your product no carbonic acid, you're going to end up having just carbon dioxide and water together with the other part of the double bond. Always look at your product and compare it with respect to the reactants. If you see that your product is less number of carbons than that of the reactants, then definitely what you're doing is oxidation, and you are forming a double bond along the way. You are cleaving it, and this is why you have loss of carbons in there, because when you cleave, you lose carbons. So the first thing that we need to do is we need to introduce an alkene in there. And this is a secondary alcohol, so we can simply do a dehydration reaction. This is an E1 reaction, just to add an acid in there. So here you go, H2SO4. We're gonna protonate the oxygen, make it water. Water is gonna leave, and then the HSO4 is gonna come and attack. The most substituted alkene will form. So I'm gonna end up having an alkene between, this is gonna be my beta hydrogen in there. Okay, between the alpha carbon and the beta hydrogen. So I'm going to end up having over here an alkene. Now, after you form your alkene, you can simply do oxidation. I'm going to do oxidation with KMnO4 in presence of water or an acid in there. So you are going to break your double bond. So once you break your double bond, what you're going to end up getting is this acid over here. We got two of them because our alkene is symmetrical. The final reaction, the last reaction, is the hydrolysis of the cyanide in basic and acidic medium. So in these types of reactions, we're going to do hydrolysis, and hydrolysis is the addition of water. The addition of water can either be in presence of a base or it can be in presence of an acid. If it's in the presence of the base, then your product is going to be the base of the acid. Look here at your reactants and your products. I didn't add any carbons, but the carbon of the cyanide turned into a carbonyl. This oxygen is due to the addition of the OH in there. The nitrogen is not seen in your organic product. The nitrogen is not here. The nitrogen left in a form of NH2 that picked a hydrogen and became NH3. I've listed the mechanism over here. Take a look at it. You are not responsible for that mechanism, but you are responsible for the product. And make sure that the product that you form always follows the medium that you're working with. Medium is basic, product needs to be a base in this case. So the nitrogen is going to leave in a form of NH2 in there, and I will introduce a carbonyl and an O negative charge on that carbon of the cyanide. Hydrolysis in the acidic medium now is going to give me a carboxylic acid because the medium is an acid, so you can get a carboxylic acid easily. And we're going to do the same thing over here. We are breaking this triple bond. The nitrogen is going to leave, because it's an acidic medium, it's going to leave in the form of an N plus. So I need to keep adding hydrogens to the nitrogen over here to make it N plus so that it can go ahead and leave. I did not add any carbons. So I'm starting with 1, 2, 3, 4 carbons. I'm going to end up with 4 carbons in there. All I did is I changed the carbon of the cyanide into a carbon double bond O. And again, that OH comes from the water. Let's have an example over here. So we want to synthesize this diacid from this dihalide. So whenever you have something like this, just think that you can change the halogens into CNs. And I know that the moment I change them into CNs, I can hydrolyze the CN. I need it to be an acidic medium directly to get the acid. If you choose the basic medium, then you have to do an additional acid step in order to change the base into an acid. So pay attention to that. Over here, I'm starting with the 3 carbons. This is 1, 2, and the 3 carbons in there. But my product is 5 carbons. These are the carbons of the cyanide. So this is how I know that I introduced a CN in there in place of the bromine. And this CN, both of these CNs, they got hydrolyzed into a carboxylic acid. So let's have an example in here, starting with this reactant. I want to prepare this diacid. So the moment you see that you're preparing a diacid, the best way to prepare a diacid is by addition of the CN and then hydrolyzing the cyanide in there. So you can easily see that I do have 4 carbons in here and I have 4 carbons in there. Okay, so what I am adding is the carboxylic acid here and the carboxylic acid there. Those two, they can come from the OH and the bromine if I manage to change both of these into a cyanide. And I can do this easily by starting with, let's start from the alcohol side. We're going to do a substitution with the alcohol. So we're going to do HCl. This is a primary, so that is going to go by SN2 mechanism. And I'm going to change this into a Cl, into a chlorine. And then after I change it into a chlorine, I can simply do NaCN in there. And I can do NaCN in excess. If I do NaCN in excess, the Cn minus is going to replace the chlorine and it's going to come and replace the bromine at the same time. Both of these are primary alkyl halides. And this is a good nucleophile. So the reaction is going to go by an SN2 mechanism in there. And I can replace both of these by the cyanide. So I have a cyanide in here. Just pay attention to the number of your carbons in there. So I have started with 4 carbons. I need to end up with 4 carbons over here. And I've introduced the cyanide. So these are my cyanides. Now I need a carboxylic acid. I can do this by either one of these steps. I can do it directly by hydrolysis of the cyanide. So I can do H2SO4 in presence of water. This is the hydrolysis of the cyanide in acidic medium. And in this case, the carbon of the cyanide will turn into a carboxylic acid. The nitrogen will leave. The carbon will turn into a carboxylic acids for each one of these cyanides in there. Or if I wish to do it in another step in there, I can do NaOH. I can do hydrolysis in basic medium. in presence of water. In this case, if I do this, I'm going to get the base of the acid. So I'm going to end up over here getting the base of the acid. It's going to be the O negative here and the O negative there. This is not my product yet. So if I do this, I would need to introduce a second step. And the second step is simply adding an acid so that you can go ahead and protonate each one of these oxygens to get your carboxylic acid. So no matter what hydrolysis medium you choose, acidic or basic, you're going to end up getting your product. But with the basic, you would need an additional step to protonate in order to get to your product.